Students, Pythagoras theorem and its application. There are two things in this particular chapter. What is the difference between the Pythagoras theorem and application of it? Pythagoras theorem is nothing but there is a square on the hypotenuse. The area of that square will be equal to sum of the squares on the other two sides. This is the Pythagoras theorem statement. It's not application. What is application? Application is hypotenuse square is equal to sum of the squares of other two sides. Sum of the squares of other two sides is equal to the hypotenuse square is the Pythagoras theorem application. And Pythagoras theorem is area of the square which is standing on the hypotenuse will be equal to the sum of the areas of the square which is standing on remaining side. This is the Pythagoras theorem. Now, we are not going to concern with the Pythagoras theorem. We are going to concern with the Pythagoras theorem's application. Now, that application we are using in different problems. The first question of your paper, or choose the correct alternative for each of the following questions. Find a perimeter of the square if its diagonal is 10 root 2 square centimeter. Now, 10 root 2 centimeter is the length of the diagonal. Being square is having all the angles 90. So diagonal square is equal to, we can apply the Pythagoras once again. That is diagonal square, that is 10 root 2 square is equal to x square plus x square if the side of the square is to be taken x. Then 2x square is equal to 100 into 2. 2 will get cancelled. X square will be 100. So x is equal to 10. Means the side of the square became 10. What will be the perimeter? Automatically 4 times it. That will be 40. So perimeter of the square will be 40 centimeter. This is the first answer. The second question. In the triangle ABC, AB is equal to 6 root 3 centimeter. AC is equal to 12 centimeter. BC is equal to 6 centimeter. Find the measurement of angle A. Now, to find out the measurement of angle A, you have to apply your mind which particular theorem we can able to take into consideration to get the value of A. That is nothing but from the option, you can understand either it is 30, 60, 90 or 45, 45, 90. 45, 45, 90 cannot be because two sides will be equal. So we will apply the 30, 60, 90 to find out measurement of A, where measurement of A in our sum, it will be 30. Now, why it will be 30? Because it is very simple to understand. AC, that is the hypotenuse, is double of the BC. Now, B and C, BC is 6 centimeter. Its opposite angle will be A and A will be 30. In that way, we can apply 30, 60, 90 theorem to get the second fill in the blank. Second question is, solve the following for finding AB and BC with the help of information given in the figure. That is, ABC is a right angle triangle and AB is one of the perpendicular side and BC is another perpendicular side where hypotenuse is AC. Okay. Now, in this particular triangle, AB is congruent to BC, it is given. Means, definitely it is isosceles triangle. And therefore, base angles are congruent. Therefore, angle A and angle C will become 45. And then applying 45, 45, 90, we can get AB is equal to BC. Therefore, BAC is equal to 45 degree as I have told. Therefore, AB is equal to BC is equal to 1 by root 2 into AC, that is 45, 45, 90 theorem. But AC is equal to root 8. So 1 by root 2 into root 8. Root 8 can be written as 2 root 2. So root 2 get cancelled. So remaining is the 2. And therefore, the answer of this question is 2. Then solve the following. What is the question? In figure, MNP is equal to 90. See MNP in the figure. Angle N. From where? Angle N. We have dropped a perpendicular NQ. That is, NQ is perpendicular to MP. MQ is given 9 and QP is given 4. We want to find out NQ. Now, to find out NQ, immediately it should come in our mind. It should come in our mind that NQ To find out, we must know the geometric mean theorem. That is, NQ square is equal to MQ into QP. NQ square is equal to MQ into QP. Therefore, NQ square is equal to MQ into QP. NQ is equal to root MQ into QP, taking the square root of both sides. Now, MQ is equal to 9, QP is equal to 4. So, therefore, 9 into 4 in the under root, you may find out 9 fours are 36 and then square root, or 9 square root and 4 square root will give you NQ is equal to 6. Okay, then the second question is to see the figure in the triangle ABC, AD perpendicular to BC, AD perpendicular to BC. Prove that AB square plus CD square, AB square plus CD square is equal to BD square plus AC square. To find out this one, very easy sum. Twice we have to apply the Pythagoras theorem, because we know that AD is common, which is the perpendicular, is common in both the triangle which is below, that is ABD, and which is above, that is ACD. Now, according to the Pythagoras theorem in ACD triangle, what is the hypotenuse? Please remember, angle DK opposite, the opposite side to the angle D, that is AC. Therefore, AC is the hypotenuse. Now, applying the Pythagoras in ADC, we will get AC square is equal to AD square plus CD square. Now, what we want, common value of the common thing we will find out. That is, AD square is equal to AC square minus CD square, and this is the equation number 1. Then, same technique we will apply to ADB triangle. In the triangle ADB, AB square is equal to, AB is the hypotenuse because it is opposite to angle D. Therefore, AB square is equal to AD square plus BD square. Now, we want to find out AD square value. So, therefore, AD square is equal to AB square minus BD square. Now, in question 1 and in question 2, AD square is same. So, therefore, left hand sides are same. So, right hand side will also be same. And hence, AC square minus CD square is equal to AB square minus BD square. Or you can write it vice versa. That is, AB square minus BD square is equal to AC square minus CD square. Just transferring negatives to another side, we will make it positive. That is, minus BD square will transfer to that side and minus CD square will transfer to this side. That will give you the final answer. That is, AB square plus CD square is equal to AC square plus BD square. Now, solve the following any one. That is the fourth question, which is having 3 marks. Here, we have to prove the Pythagoras theorem, because the statement of the Pythagoras theorem, which I have told you, it is area, sum of the areas. But here we are proving application of it, and hence in the right angle triangle, the square on the hypotenuse is equal to the sum of the squares of remaining 2 sides. To prove that one, there is a triangle ABC. There is a triangle ABC where angle B is 90. Angle B is 90, and we have to prove AC square is equal to, angle B is 90 means opposite side, that is AC, will be the hypotenuse. Therefore, hypotenuse square, that is AC square, is equal to AB square plus BC square. Construction. Draw perpendicular BD on AC such that ADC should be collinear. One thing remember, last chapter, similarity, in that one, we have studied when we drop a perpendicular from a right angle, we'll get 3 triangles, and all the 3 triangles are similar to each other. Using that particular theorem, we are writing in the right angle triangle ABC, BD perpendicular to hypotenuse AC. Therefore, triangle ABC is similar to triangle ADB is similar to triangle BDC. Similarity of right angle triangle, the name of the theorem, which I have told you. That is, when we drop a perpendicular from a right angle of a right angle triangle, whatever the number of triangles we are getting, that is 3, all the 3 number of triangles are similar to each other. Therefore, now we are considering first 2 triangles. That is, triangle ABC is similar to triangle ADB. When we are saying triangle ABC is similar to triangle ADB, we will talk about their sides are in proportion. Therefore, AB upon AD is equal to BC upon DB is equal to AC upon AB. That is, corresponding sides of similar triangles are in proportion. We have to select those ratios which can give you the numerator and denominator common, same. That is, AB upon AD is equal to AC upon AB, first and last. Okay. Now, therefore, AB square is equal to AD into AC. This is the first equation. In the same manner, we will compare triangle ABC with BDC. triangle BDC. When we are comparing triangle this and they are similar, so we will just check once again the corresponding sides of similar triangles are in proportion. Therefore, AB upon BD is equal to BC upon DC is equal to AC upon BC. Once again, we will select the numerator and denominator same. That is the last two ratios. Therefore, BC upon DC is equal to AC upon BC. Therefore, BC into BC, BC square is equal to DC into AC. In this is the second equation. Now, what to prove? AB square plus BC square. So, we will add AB square plus BC square, that is equation 1 and equation 2. By adding equation 1 and equation 2, what we will get is AB square plus BC square is equal to AD into AC, that is from 1, plus DC into AC, that is from 2. Now, here AC is common from both 1 and AD plus DC. If you will observe the diagram, AD plus DC will become AC. Therefore, AC into AC will become AC square, and therefore we can prove AC square plus AB square is equal to BC square. In this way, we can prove the Pythagoras theorem by using the similarity of the triangle. There are many means near about 232 types of proof of the Pythagoras theorem in different way. But this particular theorem proof is given in our book, and we will have to remember that one only. Now, the next sum is, in the figure, M is the midpoint. M is the midpoint of QR. PRQ is equal to 90. PRQ is equal to 90. Prove PQ square. PQ square. Observe, bigger triangle hypotenuse, PQ square, is equal to 4 times PM square, that is a median square, minus 3PR square, that is a perpendicular. Now, if you will observe, whenever midpoint question arise, whenever in the given midpoint is given, the application of Pythagoras, which is in the theorem of the Apollonius principle, that Apollonius principle we can use it. But here, we don't have to use Apollonius principle. This you have to remember. Kyunki anytime, whenever the midpoint is coming, so we are thinking about the Apollonius. Here we don't want to go for Apollonius principle. We can able to solve by using Apollonius principle. That will become a lengthy. Better to solve by application of the Pythagoras theorem. Now, this Pythagoras theorem, where we can apply? In which triangle we can apply? To get PQ square. Because our whatever it is asked to prove, that left hand side is PQ square, and PQ square contained in the triangle PRQ. So we are thinking about the triangle PRQ, where angle PRQ is equal to 90, and we are applying the Pythagoras theorem. By applying the Pythagoras theorem, we can say PQ square is equal to PR square plus RQ square. Now, RQ can be written as being a midpoint M, that is RM plus MQ whole square. In place of RQ, we have written RM plus MQ whole square, that is RMQ. Because of that one, PR square is equal to RM plus RM whole square, because M is the midpoint. So we have transferred MQ to RM. Being RM plus RM, that becomes 2RM. So the equation will become PQ square is equal to PR square plus 2RM whole square, which becomes 4RM whole square. So final equation 1 will be PQ square is equal to PR square plus 4RM square. Now, let us think about small triangle. Why we want to think about the PRM? Why not PQM? Because in the PQM, there is no right angle triangle. So we don't want to think about it. We have to think about the another right angle triangle, that is PRM. Now, in the PRM, PM is the hypotenuse. Therefore, PM square is equal to PR square plus RM square. Now, RM, it is in the equation 1, there is a 4 times RM square. And here in the equation, we are getting the RM value. So we will find out the RM value. RM square is equal to PM square minus PR square, and we will put it in equation number 1, putting equation 2 in equation 1. So what will happen? PQ square is equal to PR square plus 4 times, what is RM? RM square, that is PM square minus PR square, that is equation 4, that is equation 2. And this makes us PQ square is equal to PR square 4 times PM square minus PR square. Abhi, PR square minus 4 times PR square will become 3 PR square, and there will be the end of the sum, that which we require. We got it, that is PQ square is equal to 4 PM square minus 3 PR square. Here, even though the midpoint is there, even though the midpoint was there, we have not applied the Apollonius principle, even though it is coming in our mind. This we have to keep it in the mind, that every time if M is the midpoint or any midpoint is given, then we don't want to apply the Apollonius principle. But whatever I am saying now here in the question number 5, In the question number 5, we have to apply the Apollonius principle. How? What is the problem? That we'll see. Now, in triangle ABC, BAC is equal to 90. BL and CM are medians. Medians means midpoint. L is the midpoint, M is the midpoint. Okay. Then we have to prove 4BL square, that is the median, plus CM square, that is also the median, which is equal to 5BC square, which is the hypotenuse. To do it, we have to apply twice Apollonius. Why twice? Because we have two medians. Come on, we'll start solution. In triangle ABC, BL is the median. BL is the median. Okay. So applying the Apollonius principle, what we will get is that is AB square plus BC square. AB square plus BC square is equal to 2BL square plus 2AL square. 2AL square can be written as LA can be written as half of CA. So we have replaced AL into half of AC. So it will become AB square plus BC square is equal to 2BL square plus 2 times 1 by 2 AC square. It will become 1 by 4 AC square. 1 by 4 AC square will get cancelled with that 2 2s are, and therefore it is half of AC square. So final step will be AB square plus BC square is equal to 2BL square plus 1 by 2 AC square. Now to whole equation we will multiply by 2. 2AB square plus 2BC square is equal to 4BL square plus AC square, and we got 4BL square. Here we are reaching to our claim. In the claim, whatever it is asked, usme se one of the step we can reach, and hence we will just transfer everything from right hand side to left hand side, keeping 4BL square as it is. So 4BL square is equal to 2AB square plus 2BC square minus 2 minus AC square. This is equation number 1. As we have applied as a median BL Apollonius principle, now we will apply to the same triangle Apollonius principle by using CM as a median. Now M is the midpoint, and using side AB of the AB, and using the Apollonius principle, AC square plus BC square is equal to 2CM square plus 2BM square. Once again, BM can be written as half of AB square. Same thing we are applying. So therefore AC square plus BC square is equal to 2CM square plus 1 by 2 AB square, being 1 by 2 AB whole square ka matlab hoga 1 by 4 AB square, and 4 will be cancelled with that 2 and will give you 2 half of AB square. Now we will once again multiply by 2. So what will happen? 2AC square plus 2BC square is equal to 4CM square plus AB square. Now AB square we will transfer to that side. So what will happen? 2AC square plus 2BC square minus AB square is equal to 4CM square. Now we want, in our claim, left hand side should be 4BL square plus 4CM square, and we got 4BL square and 4CM square. So what we will do? Obviously adding equation 1 and 2. By adding equation 1 and 2, what will happen? 4BL square plus 4CM square is equal to 2AB square plus 2BC square minus AC square. Okay, that is from equation 1. And the equation 2, 2AC square plus 2BC square plus minus AB square. Here we will operate now. 2AB square and minus AB square is 1AB square. 2BC square and there is a 2BC square, that will become 4BC square. Then AC square minus AC square plus 2AC square will become AC square. That is 4BC square plus AB square plus AC square. Immediately, when we are observing AB square plus AC square, so you should look to the triangle, bigger triangle, where we can apply the Pythagoras. Yes, in triangle ABC, we have where angle BAC is equal to 90, we can apply Pythagoras to get BC square is equal to AB square plus AC square. That is equation 4. And this equation 4, we will put it in equation 3. So what will happen? See, 4 common BL square plus CM square is equal to 4BC square plus BC square, and that will become 4 bracket BL square plus CM square is equal to 5BC square. In this way, this sum may be looking big, but there are repetitions. Once, if we keep it in the mind, first thing, automatically the second thing will remain, and then addition and get the answer by just applying the Pythagoras in the bigger triangle. Okay, now next one, the last question of the paper, that is second, and this is good sum. In figure, triangle PQR, is an equilateral triangle. Point S is a segment, is on the segment QR such that QS is equal to 1 by 3 QR. QS trisect. QS is equal to 1 by 3 QR. To prove this, what we want to prove? That is 9PA square is equal to 7PQ square. Now 9PA square is equal to 7PQ square. To prove, we will consider right angle triangles in different steps, in different stages. So first, PT perpendicular to QR, okay, and QTR is the collinear point. Now PTQ is equal to 90 and angle Q is equal to 60, being an equilateral triangle, and therefore QPT will become automatically 30. Why? Because 60 plus 90 is 150, remaining angle is 30, that is sum of the angles of triangle. Now being all the angles, one is angle 30, one is angle 60 and one is angle 90. So we can apply 30, 60, 90 theorem in that PTQ triangle. What we will get is the two thing, PT is equal to root 3 by 2 PQ and QT is equal to 1 by 2 PQ. That is opposite to 60 and opposite to 30. Now keep this one in the mind, and by giving equation 1, we will go ahead. Now, QT can be written as QS plus TQ. QS plus TS. QT can be written as QS plus TS. Now, QT is equal to what? We have just proved half of PQ. So, we have put in place of QT half of PQ. Then, QS is equal to given C in the given portion, 1 by 3 QR. So, we have put 1 by 3 QR plus TS as it is. Okay, now half of PQ is equal to 1 by 3 PQ plus TS, where PQ is equal to QR being a equilateral triangle, and therefore TS is equal to, keeping TS on the same side, will transfer 1 by 3 PQ to that side, 1 by 2 PQ minus 1 by 3 PQ. Now taking out the LCM, that is 6. By taking out the LCM 6, what we will do? 3 PQ minus 2 PQ upon 6. TS will be equal to 1 upon 6 PQ. Now, let us think about the triangle PTS. Okay. In the small triangle PTS, angle PTS is equal to 90. We are applying Pythagoras. PS square is equal to PT square plus ST square. Now, we'll put once again the values from equation 1 and 2. That is, PT is equal to root 3 by 2 PQ whole square, and TS is equal to half of PQ whole square. That is by applying 30, 60, 90, what we got, that we have put it here. Therefore, 3 by 4, taking the square, 3 by 4 PQ square is plus 1 by 4 PQ square. Now, okay, that is 36 will be the LCM and will give you, by 36 LCM, 3 PQ square plus 27 PQ square plus PQ square. That will give you 28 PQ square upon 36 PQ square, which gives us, now PS square is equal to 28 upon 36 PQ square. The PS is equal to 7 by 9 PQ square. Now transferring 9 to that side, 9 PS square is equal to 7 PQ square. In that way, we can able to complete the proof. Here, one thing I am observing, that one point which I am observing, that is TS square. When I was talking, I have said 1 by 2 PQ, but it is not 1 by 2 PQ. TS is equal to 1 by 6 PQ. That is from equation 2. So automatically it becomes 1 by 36 PQ square, and rest of the thing is in the same manner. So in this way, beta, you have to solve the paper very calm and quietly. You can get the marks definitely full. Thank you. Thank you very much.